Hi, I'm Rich with insideHPC. We're here at HACC 17 in Lugano, and I'm here with Katrin. You gave a great talk today about cosmology, so congratulations on that. Can you summarize what was the talk about?
So the talk was basically about how can we simulate the universe with the biggest supercomputers available, and how can we learn more about the evolution of the universe as well as the constituents of the universe, and why do we actually need these very big supercomputers to do that? So that was the talk.
So what have been the limiting factors up till now? Is it memory, things like that? What?
It's both memory and speed. So memory because we want to get as much of a portion of the universe into the supercomputer as possible, and speed because it shouldn't take too long to do this. So we don't want to wait a year for our result to come out.
So are you representing every star in the universe as one particle, or how does it work?
No, so what we actually do is we are simulating the dark matter, which hosts the galaxies. And so what we are trying to do is to get enough resolution that we can afterwards populate our dark matter with the galaxies in a reasonable way. So we are not going down to the star level, but to the galaxy level.
So where is the dark matter? Is it all around us, or is it outside?
It hits you right now.
Yeah?
Yeah.
I've been feeling that. Okay, yeah. So it coexists in our dimension or some other dimension?
Yes. Okay. It's all around. It's 27% of the energy matter content of the universe, so it's actually much more than the baryons. That's what you and me are made of, which is only roughly 5% of what's inside the universe.
And we know it's there because we see its effects on things that we can perceive?
Right, exactly. So what we are actually looking at is the light that comes from the galaxies, and what we are seeing is that it gets bent from something that's in between us and the galaxies when we observe them. And from that, we can actually infer how much mass there should be in between us and this galaxy. And it turns out that if I would only measure or weigh the luminous mass that's in between me and that galaxy that I'm observing, I can't make up all the mass that must be there in order to bend the light from that galaxy as much as it does. And so from that I can actually see that there must be dark matter.
Do you think is it in massive objects, or is it spread around like the ether?
It's clumping, so it is in big halos, but it's all around us.
All right, so are you using PIS-DINT now, machines like that? Where are you computing?
So I would love to, especially now that it's the third largest or fastest machine in the world, so that's super impressive. Right now we are mostly doing our simulations in the US, so at Argonne National Lab as well as Oak Ridge National Lab, and also at NERSC. And so at Oak Ridge we have the same architecture that actually lives here in Lugano. And so yes, our code would be ready to go for that machine as well.
This sounds like a ever more challenging thing as you get closer to the dark matter. I'm just can't think of a wrap up. Will we ever find the dark matter, do you think?
We are building very, very big detectors, like kiloton detectors of material where we actually want to find it. And we are also looking for it at the LHC, for example. So yes, our idea is that we want to not only see it indirectly, but also directly. And really find the particles that...
And I'm just curious, why can't we see it? Does it not reflect light or something?
Exactly, it doesn't emit or absorb light, that's the problem. And it interacts very, very weakly, if at all. So right now, when we do it in the simulation, we only say it's interacting gravitationally. But we are hoping that it interacts with other matter weakly so that we actually can see it in the detectors, and that's the idea.
It's out there somewhere.